All right, reminding ourselves of the derivative of e to the f of x, or e to the stuff. The derivative is e to the stuff times the derivative of stuff. All right, here we go. So in this one here, derivative of e to the cotangent will be e to the cotangent times the derivative of cotangent, which is negative cosecant squared. And that's it. Oh, sorry, I lost the 3. Silly me. Okay, there's a 3 and there's a 3. So I carry along the 3x when I'm taking the derivative of cotangent of 3x. Now I'm going to take the derivative of 3x, so times 3. Okay, this one here, this 1 over x, make sure you rewrite it as x to the negative 1. Okay, so let's do that. So capital F of x, haven't taken the derivative yet, e to the x to the negative 1. Okay, so now you see there's product rule. So let's be careful with this. So first, derivative of e to the stuff. So that's e to the stuff. And now when I'm taking the derivative of this, it's negative x to the negative 2. Be really careful with that one. A lot of people make mistakes. And then it's plus e to the x to the negative 1. And then derivative of x, that's just 1. So let's just fix this because we will be doing things with this shortly. So I'm going to say this is this one here is e to the 1 over x. This here can be written as negative 1 over x squared, right? And then this here, I'll say this is e to the 1 over x again. So looking at this term, I see some x's canceling, right? So I would get a negative e to the 1 over x, and then plus an e to the 1 over x. All right, so let's go to this one. So it's still e to the stuff, but notice what's up in their exponent. So I have x times cosine of x. So there's product rule in the exponent. Okay, so let's be careful. Whoops. So here we go. Derivative is derivative of e to the stuff times, and I'm going to be doing product rule, so I know I need to put parentheses because I'm going to have addition. So it'd be first d second plus second d first. That's a fine answer. All right, so this one here has tangent all cubed in the exponent. So let's be careful with that. So derivative of e to the stuff is e to the stuff. And so as I'm doing this, I'm just going to rewrite it like that so that I see that it's tangent cubed. Now I'm going to take the derivative of this. So you bring the 3 down, you subtract 1 from the exponent, carry tangent of x along, then multiply by the derivative of tangent, which is secant squared. All right, reminding ourselves of this new rule, right? So if I have f of x is equal to 4 to the x, then the derivative is 4 to the x times ln of 4, right? So you're looking for that the number to the x power. And so if it's more than just x, you carry that along. You always have ln of the number and then times the derivative. Okay, so this one has quotient rule and the a to the x in there. So let's do it. So derivative will be low d high, so 3 to the x squared. It's always ln of the number and then times 2x minus high, and then d low, that's just going to give us 3x squared because the derivative of 4 is 0, all over this denominator squared. Okay, this one I see product rule. So product rule here, so taking the derivative, I get first d second. So this is 4 to the x cubed times ln of 4 times 3x squared plus the second, and then d first. So derivative of secant is secant tangent. I carry the x squared along in the angle, and then I have to multiply by the derivative of that angle, so 2x. So this, you know, is not product rule. This is just the number pi squared. So to take the derivative, we carry along pi squared, take the derivative of secant, which is secant tangent, carry the 2 to the x along, and then we're going to multiply by the derivative of 2 to the x, which is 2 to the x ln of 2. And this one here has a cosecant up in the exponent. So we know it's 3 to the cosecant of pi x, and times ln of 3, always ln of the number. Now to take the derivative of cosecant, that's negative cosecant cotangent, and I carry the pi x along. Carry pi x, and now I'm finally going to multiply by the derivative of pi x, which is pi.